Very special circumstances were required for the formation of fossil fuels that are so important to our modern life. Coal, oil, and gas are organic materials, that is, they are plant and animal remain composed mostly of reduced carbon, as is all life. As plant life evolved some 3 billion years ago, a great deal of organic material was formed, most of which was oxidized relatively soon and turned back to carbon dioxide in the atmosphere, which is not an energy source but is available for new plant growth. Some very small part of this organic material found its way to anaerobic basins, such as deep lakes or marine areas for oil and gas, and hence accumulated as various deposits. Hello my friends, welcome to my Energy Economist channel. We are going to start today by knowing the formation of fossil fuels, so stay with me. Chemically, natural gas has 4 molecules of hydrogen per molecules of carbon. Oil has about equal amounts and coal is mostly carbon, although with small amounts of hydrogen and sulfur and trace amounts of many elements including troublesome mercury and uranium. Thus, there is a progressive increase in CO2 per unit of energy delivered from natural gas to oil to coal, with coal releasing almost double the CO2 per heat unit relative to gas. The creation of exploitable oil and gas fields has been quite rare in the geologic past. It happened mostly some 90 and 150 million years ago, when the Earth was very warm and in very special and limited environments. The time required to turn the organic source material into oil and gas is extremely long and requires the organic material being buried at just the right depth and temperature about 100 Celsius degree to pressure cook the organic material into oil. As a consequence, significant quantities of commercially exploitable oil and gas are found in only a relatively few regions of the Earth's surface. Coal, formed in great freshwater swamps, required far less stringent conditions for its production and is more common. Gas too is widely dispersed, but large reservoirs are relatively rare. On the other hand, gas is found widely at low concentration associated with coal and in tight shales and sandstones. Exploitation of these diffuse resources is becoming increasingly important as the large gas fields found earlier face serious depletion. Whether or not these newer unconventional fields can maintain production at the present level for very long is unknown at this time. In this developing world, where the coal reserves are still far greater when compared to oil and gas, and hence on an average two coal-based power stations are being constructed in a week, fossil fuels will continue to serve as a primary energy source for major parts of the world for this century. Fossil fuels fulfill more than 80% of the primary energy needs. Remaining portions are made up of atomic and hydroelectricity and renewable energy. Countries like United Kingdom, which are having nuclear power and renewable energy sources, also have large coal deposits. These deposits might serve as a suitable security in the future as an energy source. Fossil fuels originate from terrestrial and aquatic plants and animals deposited and preserved in oxygen-limited and acidic environments, then buried so that the organic matter is not oxidized and returned to the biosphere as CO2. Coals usually come from wood plants deposited in swamps and bogs, while petroleum comes primarily from phytoplankton deposited in lakes and on continental shelves. Most sedimentary rocks contain disseminated organic matter. This organic matter is usually distinguished as either kerogen or bitumen. Kerogen is a principal type, and it's defined as being insoluble in non-oxidizing acids, bases, and organic solvents. Some of the organic sedimentary organic matter that is converted primarily to kerogen remains as or is converted to be soluble in organic solvents. As organic matter is buried, it continues to evolve in composition, and sometimes oil and gas are expelled from the original deposit and migrate to a reservoir. Historically, most oil and gas were produced from reservoir rocks, which can be porous sandstone or carbonate rock. Sapropelic source rocks generate primarily crude oil, although mature source rocks can also generate commercial quantities of natural gas. Coals and humic kerogens expel primarily gas during maturation, but some deposits of oil can be traced to humic coals and kerogens that contain significant amounts of algae and spores or waxy coatings on higher plant leaves. The insoluble organic matter left in the coal or source rock as it matures becomes more carbon rich. For coal, increasing carbon content corresponds to an increase in rank. Although crude oil is technically a form of bitumen, the term bitumen is more commonly synonymous with asphalt, meaning a highly viscous to semi-solid or even solid amorphous material. This usage of the term can apply to materials that were expelled or extruded from a rich source rock at low maturity or resulted from changes after migration to a reservoir. Asphaltic bitumen can be precipitated in a reservoir by solubility changes related to temperature and pressure, or increased light oil content, or can be the residue of degradation caused by water washing, seepage of light hydrocarbons through the cap rock, bacterial action, or some combination of all three. Oil shale is merely a rich, sapropelic petroleum source rock that has not been buried deeply enough to form oil and gas. The definition is more technological than scientific. The historical definition of oil shale was that it was shallow enough that it could be mined and retorted in a surface facility, although in situ forms of retorting have expanded the definition. This definition implies that the organic content is high enough that mining or drilling and retorting can be accomplished with net energy and economic gain, or that it is conceivable that it will be in the future. If you want to learn more about the formation of fossil fuels, you could do so in my book, Economics of Petroleum Principles, which is published on Amazon. Check it out at the link in the description. Please take a second to hit the like button, hit the subscribe button, and do not forget to also hit the notification bell. Thank you for watching, and goodbye.